Good morning to all. Today we are going to discuss Unit 3, Data Input and Topology, GPS Data Integration. The outcome of this topic is make use of JS software for developing raster and vector data model. The program outcome of this topic is PO1, PO3, PO5, PO6, PO7, PO9 and program specific outcome 1. The outcome of this course is make use of this JS software for developing raster and vector data models. Data preparation and integration. The necessary steps: geocoding, assigning geographic coordinates to point, pair up the most basic form of spatial data entry. Data media conversion, scanning, digitizing. Data format conversion, raster and vector. Data reduction, topology, error direction and topological editing. Rectification and registration, one on top of the other. Overlaying sheets and referencing to the real world. Edge matching and image adjustment, side by side, linking and balancing adjacent sheet. Interpolation, confliction. Geocoding, assigning spatial coordinates to point data. Address matching, assign spatial coordinates explicit location to addresses implicit location. Address matching records street network file with street attributes information, street name and number range for all street segment block size. Zone variable required if data spans multiple cities to handle duplicated street names. Precise matching of street names can be problematic. Completeness ESP dot for new street importance. PO box building names and apartment complex name and cost problems. So implementation in ArcGIS is 3 steps process. In Arc Toolbar 9.2 process street network file to create a geocoding services. On ArcMap load appropriate geocoding services via tools geocoding services manager. In ArcMap geocodes a table of addressing using tools geocoding geocode addresses. Point location file containing latitude, longitude or XY coordinates. Example derived via GPS. Bring table example in .csv or .dbf format into ArcGIS using add data icon. So right click table name in T of C and select display XY data. Display as event layer, export to shapefile or GDB features classes for spatial data sets. Input table must contain 3 variables at minimum feature ID XY. Data media conversion scanning, automated recording of map or aerial. So the products dump raster data, vectorized using conversion software, create small image using digital image processing technique. Electrochemical, electromechanical, $100 to $50,000 instrument, drum or flatbed, scan resolution depends on price. Down to 20 micros, millionth of m. So scanner versus sensor. Sensor collect data directly in digital form. Example digital cameras. Sensor resolution now 2005 greater than matches that photos. So scanning photos become old technology. Still lots of papers, maps are on example property ownership records. So the great if need only raster representation. Automated recreation of vectors data from scanning were very problematic. So document must be clean. Complex line work adds error. Lines should not be broken with text. Text may be interpreted as lines. Automatic feature detection. Road versus railroad difficult. So ESRI's Arc Scan for ArcGIS included with Arc Editor provides interactive semi-automated raster to vector conversion. Other vendors offer specialized conversion software. Digital image processing techniques used to create small raster, identify feature type within each raster. Data media conversion, digitizing, manually tracing a map or aerial. Apply to map or aerial photo, use hard copy map or photos on table, tablet or scanned image on screen, head up digitizing, pen or cursor detect XY codes. Next coordinates are in inches, some centimeters from lower left 0, 0. Control point tick marks relate digitizer coordinates to real world latitude longitude coordinate captured in stream or point mode. Accuracy of table but not user usually better than 0.1 mm. All nodes and polygons should be marked and numbered first. Essentially a vector approaches. Problems: paper map unstable, create and fold, stretch with humidity up to 3%, photos more stable 0.2%, map errors transferred to GIS, maps often prepared for display not accuracy, human and verify often generate understood, overshoot and double lines, editing and cleanup essential. Data format conversion, vector to vector, raster to raster, vector to raster point, then vector to raster line, raster to vector. So the vector to vector holds polygon, example SAS map data to point arc polygon, computationally instance, no accuracy loss providing data in clean, perfectly transitive. Raster to raster may involve resampling, C under data reduction, may involve conversion between different vendor raster format, example grid to bill. So vector to raster point, node XY assigned to closest raster cell, locationally shift almost inversible, error depends on raster size. So 2 point in one cell, disintegrated, discernible, not transferred, cannot retrieve original data without error. So vector to raster line, cells assigned if touched by line, star step appearance of diagonal lines called aliasing can be virtually improved through anti-aliasing. Brightness of cells varied based on fraction of cell covered by the line. So raster to vector by far the most difficult. Transition, the ability to reproduce the original data after conversion. So vector to raster conversion, vector, raster, point, orthogonal line, diagonal line. So more problematic. Note the use of anti-aliasing to improve lines visual appearance. So raster to vector data conversion in 3 steps. Collisions are thinning to reduce raster to unit width. So filling approaches successfully removes outer edge. Media axle approaches determination set of interior pixel feathered from outer edges. So vector extraction to identify lines. 4 connector reconstruction. So join center point of 4 connector neighbor if present. Particularly bad for diagonal line representation. So 8 connection reconstruction, join center point of 8 connector neighbor if present, diagonal line reproduce but add extra lines. So 8 connector reconstruction with redundancy elimination. If 4 connector neighbor line exit, don't draw diagonal, reduce redundant lines. So topological reconstruction, recreate topological structures. So create nodes at line junction, construct arc, define polygon, manual destination required. So available via the RSCAM extension for ArcGIS as well as via several specialized package from other vendors. So see the raster to vector conversion, sculpted zone. For example, we can use this link and you can get the more number of models. Then vector to raster, so 4 connector reconstruction, search the 4 surrounding cells and join center point if present. So raster to vector conversion, vector extraction. So 8 connector reconstruction with redundancy elimination. So from raster to from raster to raster, from raster to vector, from vector to raster, from vector to raster. So data format conversion implementation in ArcGIS 9. So the conversion one or more raster data format. So this kind of format. So raster to point, raster to polygon, raster to polygon. Then here ArcGIS data interpolation extension for the most comprehensive of conversion. So here the convert any shapefile coverage of geodatabase feature classes containing point line or polygon features on the raster datasets. So can also be accumulated through Arc catalog export function. So the data reduction. So why the convert space and then conversion time, then resampling we can change in 16 byte, 4 byte and then 1 byte. So thinning vector data, tolerance elimination, topological elimination, model based elimination. So topology and errors. So it is critical that spatial data be created and managed so that it is topological clean, free from topological errors. So detection and removal. This package commonly used topological structure checking to detect error, editing based on nodal, snapping used to correct error, moving a feature so its coordinate corresponded exactly with another's. So snapping conducted based on tolerance, snap if within 1 foot for example. So care must always be taken to assure the topological cleaning does not itself introduce error. Example, snapping nodes and line together which should not be. So the topological errors are real world occurrence. The common problems. So dancing line arc, node missing at one end, no node at arc interaction, overpass, overshoot or missing node, undershoot, then pseudo nodes but pseudo road surface changes. So pseudo arc are connected to itself, open polygon, silver polygon, then gap. How ArcGIS handle topology? So the original converged data model introduced with ArcInfo 1981 incorporate topological as part of the data. So the georeferencing we discussed already very clearly. Then transformation, translation of origin, rotation of axis, scaling of axis, tuning of axis. Then rubber sheeting, so ground control tie, then map location tick, and then GIS files. So edge matching, so corresponding feature failed to match on two sheets. So image adjustment, so raster data is made from separate image photos or tiles which are sized to produce streamless images. So collapse, image balancing and feathering, digital ortho adjustment. So color removal required, image balancing, feathering required. So NASCO digital ortho tiles before and then after. So interpolation, to create regular spacing from irregular data. So interpolation we can use a spread how much it will be affected, the things we can find very easily through the interpolation, weightage of function, trend surface approaches. So then conflation, so create new master coverage from the best spatial and attributes quality up to or more source coverages, create new master coverage from quality spatial data in one sources and quality attributes data in another. So Navstar Global Position System, factor affecting GPS accuracy in aerospace, troposphere, multipath, emperorous, blockage of satellite signal. So overall accuracy better at night than during day. So the assessment for the session, how to data integrated in GIS. So these are the reference material. Thank you.